Okay. Well, there isn't too much left to say. Ein arba shenashir laomer עכשיו. אבל אני רציתי לדבר באנגלית. אני לא יודע, these people, how many people, כמה פה יכולים לדבר באנגלית? לא הרבה, All right. All right, well, I'll just make it fast. I'll make it fast. There's not much left time anyway. So we talked about in the past. We talked in the other people have talked about here. Professor Silman, Professor Bentwich. They talked about the conflict between quantum physics and relativity, and that this is the fundamental question. This is the fundamental conflict that's occurred over the last 80 years in physics. A few things that I want to talk about are what some of the solutions to that problem are right now, and how those solutions are in fact no solution, and how the scientists themselves, the physicists themselves, are coming to that realization. First, I just want to say a few words about quantum mechanics, and I'm really making this very short because I understand everybody wants to go home. But quantum mechanics, as Professor Silman was saying and Professor Bentwich, it's something which is nifla. Quantum mechanics does not make any sense. You have particles, they can do wondrous things. You think they're a hard little piece of matter, but they're not. A particle can go right through a wall. A particle can be in two places at one time. A particle can be connected to each other across the entire universe at the exact same moment. A particle can do it's called superposition. Particles can appear out of empty space from nothing. Yesh ma'ayin. This is all physics. This is not Hasidut. This is physics. Particles come out yesh ma'ayin, out of complete nothingness. They do extraordinary things. The quantum mechanics, in and of itself, is something just incredible. I could go into more and more details, but I, don't have a lot of time. And also, so the big conflict is between, like I said, quantum mechanics and relativity. Relativity is also something absolutely amazing. Relativity basically says, everybody knows E equals mc squared. What is E equals mc squared? It's that energy, the thing which is moving things, is the same thing as the thing which is not moving, as the mass. Except only it's betzimtzum. The mass is betzimtzum achum. Okay? How much? I always do this little demonstration. Everybody knows what happened in Hiroshima and Nagasaki. But what most people don't know is how much actual matter was converted into mass. What destroyed the city of Hiroshima and Nagasaki was the amount of mass that's on the head of this pin. This is what got transmuted into energy, just what's on the head of this pin. That's because the amount of energy which is locked up in even the smallest bit of matter is enormous. You have to multiply by 90 quadrillion to get the amount of, you multiply the amount of mass by 90 quadrillion to get the amount of energy that's locked up in a little piece of mass. So how much energy, kama hatzimtzum, the kol haguf shel shulchan, haguf shel shelanu. Again, this is not Hasidut. This is modern physics. Modern physics is confirming everything which was said in Hasidut. So, like I said, so the big conflict is between quantum physics and relativity. These things do not go together. Quantum mechanics and relativity do not go together bichlal. And for the last 80 years, the scientists have been trying to discover a way to bring them to lock them together, to unify them, so that because 3 out of the 4 forces, the nuclear strong force, the nuclear weak force, and electromagnetism, those 3 can be unified, but not with gravity. Gravity is a relativistic force, and it cannot be unified with the other 3 forces. By the way, I should just mention, I don't, the PowerPoint's not working, but the standard model of modern physics says that there are 12 basic particles. Okay, there's 12 quarks, which make up neutrons and protons, and also more exotic matter. And then there's electrons, and the electron has 2 cousins, and a neutrino also has 2 cousins. It makes up exactly 12 particles, and they're arranged in a pattern of 3 by 4, like 3, 3, 3, 3, like this, exactly like the Choshen Mishpat. Exactly like the Choshen Mishpat, which is on the Kohen Gadol, which is what? They're just the stones, the basic particles of matter. So the one attempt, the most successful attempt to unify quantum mechanics and physics, quantum mechanics and relativity, so far is called string theory. String theory posits that all matter and all energy is made up of tiny little strings. Okay, tiny little vibrating strings, and that these strings. But the catch is that these strings, they vibrate not in 3 dimensions, and we have 3 dimensions of space: length, width, and height, plus 1 of time. So they do not vibrate in just 3 dimensions, but in fact in the following possible dimensions: 10, 11, or 26. Only those numbers: 10, 11, or 26. We all know what those are. I mean, there are 10 or 11 sphirot. And the 26, by the way, the 26 dimensions is only for the energy particles. Only energy particles vibrate in 26 dimensions. So this is not Chassidut. This is not Kabbalah. This is modern physics. This is coming out of the mathematics of modern physics. 10, 11, or 26. So on top of that, there's several problems with string theory. One is that these strings are so incredibly tiny, they're so incredibly small, that it's basically impossible that we're ever going to be able to prove that they exist experimentally. That's one problem with the string theory. So it's only of mathematical construction, and it only has to be taken on faith. And the second problem with string theory is that so where are these other dimensions? Where are these other dimensions that we don't see? They're curled up in what's called a Calabi-Yau space, which is a very tiny curled up space, which has 6 dimensions, 6 curled up dimensions. Now, what's very interesting about this is that these 6 dimensions are, they exactly correspond to the 6 dimensions of the Vav. We have Yud, K, Vav, K, right? So the Vav has 6 dimensions within it. The Vav has a value of 6. So this corresponds exactly. On top of that, the number of possible ways in which these Calabi-Yau spaces can be organized is 10 to the 500. That's a 1 with 500 zeros. So this is the second problem with string theory, because there are an incredible number of possible universes that can be made with these Calabi-Yau spaces. So this is the basic problem with string theory. On the one hand, it does the job. It unifies gravity with relativity with quantum mechanics. But the problem is that there's these hidden dimensions which we cannot prove. The strings themselves are incredibly small, and it doesn't define one particular universe. In fact, it defines a huge, almost an infinite number of possible universes. So the question is, where is our universe? So, and this is just the last thing I'll talk about, because I see we're all heading home. But there's a final problem with modern physics, which is basically they're banging their head against the wall at this point, and that is the fine-tuning problem. The fine-tuning problem is this: all the constants of nature, the gravitational force, all the masses of the particles, the charges of the particles, there's a number called the cosmological constant, which is what causes it's like an anti-gravity force which is causing the expansion of the universe. These numbers have to be precise to 100, for example, the cosmological constant has to be precise to 123 decimal places. 123 decimal, that's a decimal point with 123 zeros. 123 zeros, and at the end, a 2. If this number was, instead of a 2, it was a 3, then the universe would expand too fast, and there would be no stars, there'd be no galaxies, there'd be no life, and the universe could not exist as we know it. If the 2 instead was a 1, then the universe would collapse too fast. It wouldn't expand fast enough. The universe would collapse too fast, and again, there would be no life. There are many, many examples of this. Gravitation, for example. The fact that I can drop this on the floor. It falls that fast and no faster. If it fell any faster, and when I say any faster, I mean 1 part in 10 to the 60th. That's 1 with 60 zeros. 60 zeros. You know how much that is? I had a PowerPoint thing on this. It's all the sand in the entire world. Kol hachol b'kol olam. If haya od tipa shachol, ze yoter midai. If im haya ze chaser rak gragira echad v'kol hachol ba'olam ze lo maspik. And in that case, our universe would not exist as we know it. This is called the fine-tuning problem. All the numbers, all the constants of nature are tuned to exactly the right number. Now, how is this possible? So the scientists these days have 3 possible solutions. One is that, well, there must be some necessity for this. This must come out of some equation. But they've never been able to find an equation, and they're beginning to despair of ever finding such an equation. The second possibility is that it's just chance. We got very lucky. We got extremely lucky. Well, of course, that's just nonsense. You can't have 123 zeros, and 60 decimal places for gravity and just call it luck. And the third possibility, now there's a fourth possibility. The fourth possibility is, well, maybe we'll figure it out one day. All right. The third possibility, and this is well, actually, I'm sort of skipping ahead because I'm quoting somebody now. I'm quoting Professor Leonard Susskind, who's one of the inventors of string theory. And he listed the possibilities. So he said the third possibility, and this is what they're saying, is that, well, the 10 to the 500, there are 10 to the 500 possible universes with string theory. So we just happen to live in the good one, right? We have all these possible universes, 10 to the 500 possible universes, and we just happen to live in the one that happens to come out right. Of course, the problem with this is that we will never discover these universes because they're other universes. So it's not really science. It's just theory. And string theory itself cannot be proven. So, of course, his first answer, when he's asked this question, his first answer was simply God. So this is where physics is, and I'm just taking him as an example because he's one of the cutting-edge physicists. This is where physics is standing right now. Physics is standing on the point where they're saying, well, the only hope we have of not resorting to God, of not relying on God for the answer of why the universe is the way it is that there's an infinite number of possible universes and we just happen to be living in the good one. Of course, they'll never be able to prove that those other universes exist. On top of that, they themselves recognize that this is a long shot. They say, I have a quote here. I did this just today. I happened to see this just today. Maybe I'll just read this to you. Actually, I'm going to read 2 things. I read this and I'll read one more thing. And it's too bad because I have a video of this. Where is it? I'm quoting Leonard Susskind now, okay? He says, well, you have to go back. He's talking about this idea of one more thing I want to say about the fine-tuning problem. So what the answer to the fine-tuning, that they have now is called the anthropic principle. The anthropic principle is now a true theory in physics that basically the universe somehow is fine-tuned for life. It's fine-tuned for human beings. Somehow the universe was made on some level for the sake of human beings. Now there's 2 versions of this. There's what's called the weak anthropic principle, which is basically the one I just said. That basically there's 10 to the 5. There's a huge infinite number, a huge number of possible universes, and we just happen to live in the Goldilocks universe where everything just comes out just right. Okay, I'm dead serious about this now. I know you're laughing, but this is where they're standing. Okay, okay, and then there's a second anthropic principle, which of course is that God created it. Basically, that God created the universe for our sake. Okay, and these are the only two possibilities now. This is where this is where the physics is holding it at this moment. Let me just read you what Professor Susskind says about the weak anthropic principle. And I just saw this today. So you have to go back a dozen years or so, this is him now, to what physicists thought about these anthropic ideas. They thought of them as being religious. They thought of them as being the statement that the world is the way it is because God made it so that people could exist. Physicists don't like to explain things that way. I'm quoting him now. They want the hard-nosed equations. They want hard-nosed explanations based on the laws of science and so forth. So they were very, very, I would say, almost angry. There was almost an anger at this idea that the universe was somehow made for us to live in. That, how shall I call it, that a mindset. It was the mindset about the anthropic principle, let us say, 10 or 12 years ago. It just rankled against physicists' objectivity to introduce something as personal as saying the world is made for us to exist in. But as time went on, that was 10 or 12 years ago now. As time went on, and this video was just like about a year ago, they found it less and less possible to explain the world as we see it, and new kinds of explanations evolved which were not religious in the least. They depended on this enormous diversity. Okay, so this is the weak anthropic principle now. Okay, they depend on this enormous diversity, this huge number of possible universes. Okay, to explain the idea that, well, we just happen to live in the good one, that they had in the back of their mind. Oh, but they had in the back of their mind always that there was some supernatural aspect to it. Okay, the other thing was ambition. I'm still quoting him. I don't mean personal ambition. I mean the ambition of the field. The ambition of the field was to explain every single fact of nature, the constants of nature, the particles of nature. The hope was that we would be able to use our equations to explain every single feature of nature, and that just conflicted with the idea that nature could be enormously diverse. It is almost as if at one time biologists had the ambition to predict exactly what a human being was like from the microscopic laws of chemistry. Well, that didn't happen. That's not the way it worked. The human being could have had 3 ears, he could have had 2 noses. All kinds of differences could have been inherent in the DNA. And the biologists, had they had the ambition, would have been frustrated. Some of them might have even gotten angry and said, oh, it can't be that way. That's kind of what happened. The ambition of physics to explain everything uniquely by some fundamental mathematical beautiful laws, elegant laws, got frustrated, and so for a period of time, physicists resisted this. They resisted this idea of this anthropic principle. I would say that by now that there's been a reversal of fortune. Most physicists recognize if you were to hold a gun to their head and say, explain to me the fine tunings of nature, and if you don't give me the right explanation, I'm going to pull the trigger. Okay? Or you say, God, that would be worse. That's what he says. That would be worse. Then they would say, okay, it must be the multiverse and the landscape of string theory because there is no other explanation. So there's been a reversal of fortune. On the other hand, we're all unhappy that our ambitions have been frustrated we're all unhappy that our ambitions have been frustrated. So some people, myself included incidentally, would say that it's too early to give up the ambition. But it's not too early to start to think about the other possibilities. And in fact, the other possibility is namely this grand anthropic multiverse landscape picture that one seems to be the way that most physicists are going now, like it or not. So the physicists are essentially saying, we're giving up. We're not going to solve all the riddles of the universe. We don't have answers for everything. And they're saying, well, okay, so there may be an infinite number of possible universes, a huge number of possible universes, which, by the way, is not against Torah, because Hashem said, it says it's written in the Torah that Hashem created worlds, He destroyed worlds, there are worlds upon worlds, so that even that does not go against Torah. But they're being dragged, kicking and screaming against their own will, to a conclusion, basically, that they're not, that Hashem created the universe. This is what it comes down to. I'll just give you one more quote. So, like I was saying, their numbers, the cosmological constant, like I said, is 123 zeros and a 2. Okay? And they explain the 123 zeros using the string theory, because there's 10 to the 500 possible possible arrangements of the Calabi-Yau space. So that there's 10 to the 500 possible universes. So therefore, you've got 10 to the 500 possible universes, and therefore you can explain, a number like 10 to the 123, right? Because you got 10 to the 500, so you win, you're bigger, all right? But regarding Susskind's multiverse idea, this whole idea of the multiverse, okay, Sir Roger Penrose, who's professor of mathematical physics at Oxford University, has said, now usually when people talk about this fine-tuning, the fine-tuning we were just talking about, they're talking about the constants of nature, which conceivably have been quite different values. And it's certainly the case that if these numbers had even slightly different values, and sometimes extremely slightly values, then life as we know it could not have happened. But then there's fine-tuning in the origin of the universe, which has to do with the second law of thermodynamics. It has to have been extraordinarily precise. In fact, and now he's talking about now, is the mass-energy distribution of the universe at the moment of creation. At the moment of the Big Bang, what was the ratio between the amount of energy and the amount of matter? That has to be precise to 1 part in 10 to the power of 10 to the power of 123. That means 10 to the 1,230. That means a 1 with 1,230 zeros after it. Now that's a ridiculous number. I'm quoting him now. That's a ridiculous number. People worry about the constants of nature. So you want to fix those constants. But that's nothing by comparison with this number. The precision that we see in the initial state of the universe completely dwarfs any of those other considerations. What this means is that the anthropic argument is useless for explaining why the universe is so precise. It has to be a completely different kind of explanation. I mean that you can't say, well, there are a lot of universes out there, and that the one we happen to be in is just right. That doesn't explain it. We don't get anywhere close to that. Okay, it might have something to say about those few constants of nature which we have trouble in explaining, why they fit together in certain ways. But that's chicken feed. I'm quoting him, Sir Roger Penrose. That's chicken feed by comparison with the special nature of the Big Bang. And the anthropic argument gets you nowhere. So what he's saying is, as good as the anthropic argument is, as good as this idea of the multiverse idea is, okay, because you got 10 to the 500 possible string theories, okay, that doesn't get you anywhere because the initial state of the universe, when the universe was first created, had to be precise to 10 to the 1,230. So it doesn't get it anywhere. So what's happening right now, the cutting edge of physics, where the state of the art is right now, is that physics is bumping up against impossible problems that they themselves recognize are impossible to solve. You cannot discover another universe. There's no way, because it's a different universe. How can you discover it? Okay? The strings themselves, and by the way, strings do sort of fit in with the Torah because, Hashem created the universe, He created the infinite light, then He created the Tzimtzum, okay? And then He put into the Tzimtzum a Kav. The Kav which went into the center of the Tzimtzum. And the Kav itself is made up of tiny yuds. The Kav itself is not a single string. It's made up itself of tiny little strings. So the string theory actually fits very well with what Kabbalah says. And what's the value of yud? It's 10, which vibrates in 10 dimensions. So it's very interesting that they came up with the string theory. But nevertheless, the string theory itself says that there is a huge number of possible universes. And yet even that is not sufficient to explain the extraordinary precision of the constants of nature, the extraordinary precision with which Hashem created the universe. And if any of those numbers were even slightly off, if you were slightly bigger or slightly smaller, even by the tiniest smidgen, then the universe would not exist as we know it. There would be no stars, there'd be no planets, there'd be no life, and most of all, there'd be no human beings. There'd be no consciousness, there'd be no free will. I think as Professor Silman already mentioned, in quantum mechanics, that observing as the particle comes through the double slit, if you observe it, you change it. The act of observation by a free-willed observer changes the nature of the observation. That means that human beings are fundamental to the universe. Oh, I've got one more quote for you. I'm going to save this one for the end. Hold on 1 second. It's at the end. I'm doing this sort of piecemeal. Here, actually, I'll read my last paragraph here. Oh, I'll read my last little bit here. This is my conclusion. This is the conclusion that I wrote. All right, which brings us back to the flood. We said that the flood, right, that that in the 6th century, the 6th millennium, that the knowledge of God would begin to flood the world. That the upper waters and the lower waters, the upper waters being the Chassidut and the Pneumis Torah, and the lower waters being the knowledge of the physical world, the scientific knowledge of the physical world, that those waters begin to flood the world in preparation for the seventh millennium, for the coming of Mashiach. Okay? In 1982, American inventor Buckminster Fuller estimated that if we took all the knowledge that mankind had accumulated and transmitted by the year 1 of the Common Era, so in other words, you took everything that human beings knew from the beginning of, from Adam all the way to say the destruction of the temple, okay? And you said that's 1 unit of knowledge, okay? That's 1 unit of knowledge. Everything we learned from day 1 until the destruction of the temple, that was 1 unit of knowledge, okay? How long did it take for that knowledge to double? Well, it took until the year 1500, okay? So it took from everything we learned from, from 0 to, destruction of the temple. What is that? 2,000, how many, 3,000, 4,000 years? 4,000 years maybe? 4,000 years. 3828, there you go. Okay, so 4,000 years almost. Everything we learned up from then, from beginning until then, that's 1 unit of knowledge. How long did it take for our knowledge to double? To the year 1500. The next doubling of knowledge took only 250 years, to the year 1750. By 1900, 150 years later, doubled again. By the end of World War II, knowledge was doubling every 25 years. Today, human knowledge is doubling approximately every 13 months. According to IBM, within the next 10 years, knowledge will be doubling every 12 hours. The sum total of human knowledge will be doubling every 12 hours. If that's not a flood of knowledge, I don't know what is, okay? So, and I'm doing this conclusion based on the idea that I did this whole speech, which I didn't. So I'm going to do the conclusion anyway, all right? So as we have seen, since the dawn of the 6th century of the 6th millennium, due to the hidden influence of the upper waters becoming revealed through the teachings of the Baal Shem Tov and the Alter Rebbe, the lower waters, our understanding of nature, has been utterly transformed from a Greek-inspired, mechanistic, cause and effect, godless structure, devoid of free will and a role for mankind, because before quantum mechanics, everything was mechanistic. You had basically little balls bumping into each other. It's a clockwork universe, right? Then when quantum mechanics came along, they had to throw that out because they realized that the universe does not work that way at all. Let's see. Godless structure, devoid of free will and a role for mankind, into an indeterminate, probabilistic, relativistic universe where miracles are everyday occurrences. Man plays an indispensable role, and even the most hardened rationalists are nearly compelled to admit the inevitability of an intelligent designer. We have seen that what was once thought of as hard physical reality is nearly empty space, teeming with unimaginable forces and energy, because this physical matter, there's nothing physical here. Okay? The reason my hand doesn't go through the table, if the nucleus of the atom was the size of a ping pong ball, the first electron would be at Harabayat. And what's in between the nucleus and the electron? Nothing. So it's mostly empty space. And why does my hand not go through that empty space? Because the electrons in the desk, they magnetically repel the electrons in my hand. That's why my hand doesn't go through the table. It's not because there's something hard and physical there. It's only because of a magnetic force. So the physical world, if you could see with those eyes, if you could open your eyes and see with those eyes, you wouldn't see a physical reality. You would see basically mostly empty space and only a tiny little bit of matter. And what is that matter itself? It's only energy extremely condensed. It's just condensed energy. Let's see, where was I? Okay, that even the little matter present is merely a form of energy highly, highly condensed, as I was just saying. That particles can slip through solid walls, disappear from one place and reappear in another. The lights right here, when the electrons, they go from when the electrons, they get excited and they go from one state to another, they don't jump from here to there. They disappear from one place and reappear in the next place. It's called a quantum jump. But it's not really a jump. If I jump, if you took a movie, you could see all the steps. right? But with these, you don't. They disappear in one place and reappear in the other. Particles are doing this all the time. They appear spontaneously yesh ma'ayin out of empty space and become entangled with each other such that they are in instant and intimate communication. That space and time are a fluid and relativistic fabric, as the Torah describes it, because we now know that space itself is like a fabric, and that it can curve, it can bend. Even a few years ago, 2 years ago, they discovered there were gravity waves. Just like you can take a sheet and give it a snap, and you get a wave in the sheet, the same with space. If you have a strong enough event, like two black holes smashing into each other, so you get waves of gravity. You get literally the space, space itself literally waves, which is something that Einstein predicted. Relativistic fabric that can stretch and bend and warp. That the two pillars of modern physics, quantum mechanics and relativity, can only be united into a single unified whole if reality consists of 10, 11, or 26 dimensions, as the Kabbalah has asserted for over 4,000 years. Finally, we have seen that the universe is so finely and precisely tuned to permit our existence that the entire worldwide scientific community is arriving at the nearly inescapable conclusion that only God must have created it. Is this not the beginning of the fulfillment of the prophecy that the entire world would be occupied only in knowing God, and that the knowledge of God would fill the earth as the oceans cover the seabeds, and that all mankind would speak with a single speech and declare the glory of the Creator? Is this not the Geula the Rebbe announced, that the Lord will be king over the entire earth, and that on that day the Lord will be one and his name one? I'll leave you with the words of physics professor John Archibald Wheeler, not Jewish by the way, who's a professor at Princeton, astronomy professor at Princeton, who said, "Is man an unimportant bit of dust on an unimportant planet in an unimportant galaxy somewhere in the vastness of space? No. The necessity to produce life lies at the center of the universe's whole machinery and design. The existence of an observer is as necessary for the creation of the universe as the universe is necessary for the creation of the observer. Without an observer, there are no laws of physics. Why should the universe exist at all? The explanation must be so simple and so beautiful that when we see it, we will all say, how could it have been otherwise? Still needed today is a thinker who can lead the way sure-footedly through this world of mystery to insights overlooked or deemed impossible. I don't know how to. I don't know anyone who does. I can only say that when you see the one who does, treasure him or her." I would suggest that we have such a thinker. His name is Rabbi Menachem Mendel Schneerson, the Lubavitcher Rebbe, the Melech HaMashiach, and we do indeed treasure him, and we impatiently await his prophesied and imminent re-revelation, Tekef Miyad Mamash. Yechi Adonenu Mereinu V'Rabbeinu, Melech HaMashiach L'Amved.